Okay, so third video in section 1F, we're going to be talking about graphing lines. All right, so we're just going to take what we learned about finding the equation of a line and sort of working backwards. Okay, so if you have an equation that can be written as y equals a number, remember we're using y equals b, so if it can be rewritten somehow to be y equals 5 or something like that, there's only a y in the equation, then the line is horizontal. Okay, and then it's through whatever y coordinate that number is. Right? So those are easy if you can recognize it. Okay, if the equation can be rewritten as x equals a number, so it doesn't have any y's in the equation, it only has x's, then you know it's going to be vertical. Okay, it'll be vertical through the x coordinate that's in the equation of the line. So those are both pretty easy if you happen to notice that they're there. Most lines are going to be y equals mx plus b lines, possibly after you rearrange them a little bit. Okay, so for these, you're going to start at the y-intercept. Okay, so that's going to be your first point, 0, b, that y-intercept. All right, and then use that slope, m, and think of it as rise over run. Okay, so we need to think of m as a fraction, and we'll think of it as rise over run. All right, and we'll talk about how to do that. Okay, so I'm just going to give us a few lines to graph. And I did mention on Moodle, if you go on Moodle where I have handouts, there's a tab display for handouts, and one of them is a tab that says graph paper, and it has this exact set of axes. So if you feel uncomfortable drawing your own axes with tick marks to graph, and you feel like you'll do a better job graphing with graph paper, you can go ahead and print out a couple of copies of that. That'd be fine. And on your exams, I usually give you graph paper just to make sure that I force you to draw neat graphs. Okay, so let's see. So our first one, we're going to graph the line with this equation, y equals 2x plus 5. And this is almost exactly like the line we plotted points with, but we're going to be more sophisticated. We don't want to plot points. I'm going to do this by graphing it like a line. Okay, so remember that this number is our m, our slope, and this number, that positive 5, is our b, that's our y-intercept. Okay, so I'm going to start, okay, if it's a y equals mx plus b, you're going to start by plotting the y-intercept. So we're going to plot that point 0, 5. That's our first point. All right, and then we're going to travel using the slope. Okay, so our slope is m equals 5. Sorry, not 5, 2. Our m is equal to 2. Now we want to think about that as rise over run. So I'm going to write that as 2 over 1 so that we can think of that as rise over run. Okay, both of those numbers are positive. 2 and 1 are both positive. Okay, so we're going to rise. We're going to go in the positive y direction. We're going to go up 2, and we're going to go in the positive x direction, which is to the right. So we're going to go up 2 and to the right 1. Okay, so starting at that y-intercept over here of 0, 5, I'm going to go up 2 units to 7 and to the right 1, and that's going to give me the point 1, 7. All right, now you only need 2 points to graph a line, so you can be done here if you would like. But I'm going to plot another point. I'm going to show you kind of a trick. All right, so I'm going to think about my slope. My slope is 2, and I'm going to rewrite that slope. Instead of as 2 over 1, I'm going to write that as negative 2 over negative 1. Okay, so stare at that for a minute. I'll tell you why I did that in a second. Okay, but that's still the number 2, right? Because I put a negative on top and a negative on bottom, that's still the number positive 2. So this is still the slope of this line, just rewritten in a different way. Now, why did I do that? Because now when I think about rise over run, okay, it's still a slope of 2, but now I'm going to rise in the negative direction. So we're kind of falling rather than rising. So we're going to go down, and my run is also negative. Negative for the x direction means to the left. Okay, so instead of going up 1 and to the right, up 2 and to the right 1, which I did for the last point, I'm going to go down 2 and to the left 1. So from that 5 on my y-intercept, I'm going to go down 2 and to the left 1. And that puts me at that point, -1, 3. All right, and I can keep doing this, either going up 2 and to the right 1 or down 2 and to the left 1. So from that point, -1, 3, I can go down 2 more tick marks and to the left. Down 2 and to the left. Okay, again, overkill. I did not need to plot 700 points to graph this line. We get the idea. Okay, but you can plot as many points as you want, and you can go right or left. You just have to adjust and make sure that that ratio, that m, always divides out to give you the same number. Okay, so I'm going to attempt to draw a straight line here, but we might have to use our imaginations. There we go. And again, always go past the points that you plot. Excuse me. With some arrows to just kind of imply that the graph keeps going in both directions. All right, so perfect. All right, so that's how we're going to graph a line if it can be written as y equals mx plus b, and we'll come across another one of those in a minute. All right. Okay, so let's do our next one. Our next line, graph the line 2x minus 3 equals 0. Okay, so it's kind of tempting when you look at this one to think of this as y equals 2x minus 3, but there is no y in this equation. I wrote 2x minus 3 equals 0, and that kind of looks like a linear equation that we might have solved a couple of sections ago, so this doesn't even look like the equation of a line. But let's see what happens when I actually solve it. So like if I add 3 to both sides, I'm going to rearrange this, and then divide by 2. I get x equals 3/2. Okay, so x equals 3/2. You kind of back up a couple of minutes on the video. Remember, if you have an equation that is x equals a number, there's no y's in the equation, that's the equation of a vertical line. Okay, a vertical line. So this is the line where all the x coordinates are 3/2. Okay, 3/2, also known as 1.5, so that helps. All right. So I'm going to plot the line that has all x coordinates of 1.5. Okay, so on the x-axis, 1.5, at 3, 1.5, at 4, 1.5. Okay, all of my x coordinates. Anywhere I might pick a y coordinate, always I'm coming up with an x coordinate of 1.5. Okay, so this line is very boring. Its answer is always that x equals 1.5. It doesn't care where you put the y coordinate, it always wants that x equals 1.5. Okay, so I'm going to grab my line and draw it through all these points like that. Okay. All right, so as long as you go past those dots, you can put the arrows or not. There at the end. Oops, it's a very fat arrow. Okay, so that's a vertical line. So like I said, the equation looks a little bit weird at first, all right, but you have to recognize if you're graphing an equation of a line, there's not going to be a y in the equation. It's only going to have x's in the equations. All right. So next one, let's go on to the line x plus 3y equals 3. Okay, so this one is not horizontal or vertical. It has both an x and a y in the equation, so it's going to be a regular equation of a line. All right, but it's sort of not solved the way we like it. We like it to look like y equals mx plus b. All right, so I'm going to solve this equation for y, so it'll look like a y equals mx plus b line. I'm going to subtract x from both sides. So I get 3y on the left, negative x, plus 3 on the right. And then I'm going to divide everybody by 3. Divide both sides. Okay, so we kind of distribute that division over here. So I have negative x over 3 plus 3 over 3, which is 1. All right. And I'm going to rewrite that negative x over 3 because we know this is mx plus b, so I want it to look like I've got a number stuck to the x over there on the left. So I'm going to write y equals, I'm going to write that as negative 1/3 x plus 1. Okay, so y equals negative 1/3 x plus 1. Okay, if you're having a hard time understanding why that's the same thing, kind of think off to the side. Negative 1/3 times x is the same as negative 1/3 times x over 1, okay, which is negative x over 3. All right, so negative 1/3 x plus 1. All right, so I'm going to recopy that. Let's get rid of all this stuff here. Okay, so I'm going to recopy that negative 1/3 x plus 1 up at the top so I can... Okay, so we know that the 1 is going to be our y-intercept, so we're going to start off at 0, 1. So I'm just going to plot that point. And then we're going to think about our slope as being negative 1/3. Okay, and I'm going to write that negative 1/3 two different ways. I'm going to write it as negative 1/3. I'm also going to write it as 1/3. As long as I only put one negative sign in the fraction, that's still the number negative 1/3. Okay, and the reason I do this is so that my rise over run okay, if I write it as negative 1/3, my rise, the top, is negative, and my run is positive. So I can go down 1 and to the right 3, or if I think of it as 1/-3, I can choose to go rise 1, that would be positive 1 would be up, and run -3, which would be up and to the left. And you'll see that no matter which one of those I pick, I'm going to lay on the same line. Okay, so I'm going to start over here with negative 1/3, down 1 to the right 3. Okay, so I start off at my y-intercept. I'm going to go down 1 and to the right 3. And that should land you at an x-intercept of 3. All right, so I can keep doing that even from that point. From that point, I can go down 1 to the right 3. Down 1 to the right 3 would take me off my graph paper. Okay, so absolutely, I've got enough to graph the line. You do not need to keep going. All right, I'm just trying to show you how you would do this. Okay, so that was going down and to the right, and then I said I could also go up and to the left as long as I keep that ratio of 1/3 going. Okay, so I'm going to go back to my y-intercept up here at 0, 1, and I'm going to go up 1 tick mark and to the left 3. Okay, you can see that that makes me land right on the same exact line. So I can go up 1 and to the left 3. All right, so you can go graph in either direction, whichever one is more convenient. All right. All right, then I'm going to grab my line tool and I'm going to graph this line. Going through all those points. And again, extend your line beyond the points that you plot. All right, and I'll give it my fat arrows here at the end. Arrows are kind of optional. As long as you don't end at a filled-in dot, it kind of implies that it keeps going. So you can draw the arrows or not. All right. Okay, so there's our graph. Okay, so we've graphed one with a positive slope, one with a negative slope. We've graphed a vertical one. Okay, let's do one more. Okay, so D, we're going to graph the equation 4 plus 4y equals 0. Again, this one looks a little bit weird. It only has a y in the equation. Okay, so let's solve for that y. I'm going to subtract 4. 4y equals -4, divide by 4. Y equals -1. Okay, so again, this is the equation of a horizontal line. Okay, this line is very boring. No matter what question you ask it, it always answers y equals -1. That's the only thing it wants to talk about. Okay, so y equals -1. Okay, so this is all the points where the y coordinate is -1. Does not matter which x coordinate I pick, the y-coordinate is always -1. Again, not necessary that you plot 300 points. You could just go ahead and graph the line straight away. Okay, this is just the horizontal line that goes through y equals -1. Okay, and there it is. And again, you can put the arrows at the end if you want to, or you can just kind of leave it. As long as you don't stop at one of those filled-in dots, then it'll imply that it keeps going. Okay, so that's how we graph it. You want to look at the equation. Can you write it as a y equals mx plus b? Can you write it as an x equals a number? Can you write it as a y equals number? All right, so the last thing that I want to talk about in this section, be just kind of quick, is parallel and perpendicular lines. You can kind of beat this topic to death, but I'm going to make it really straightforward and simple. Okay, so we'll say parallel. So parallel lines are lines that they never intersect. Okay, so they could both be horizontal, they could both be vertical. All right, but no matter what is going on, parallel lines always have the same slope. Their rise over run is going to be the same, and that keeps them from running into each other. Okay, so parallel lines have the same slope. Okay, so they might be both a 2x or a 5x, whatever that slope is, that number that's attached to the x is always going to be the same for parallel lines. Okay, perpendicular lines again are these ones that meet at right angles. Okay, so you could have a horizontal one and a vertical one that meet at right angles. You could have one of them on an angle, okay, and then the other one would come and meet that at a right angle. Okay, so either one's horizontal and one's vertical, or one of them's going to have a positive slope and the other one's going to have a negative slope. Okay, so the way you can tell by looking at the numbers, perpendicular lines have slopes that are negative reciprocals. I'll tell you what that means in a second. Okay, so for example, if your slope of your first line is 1/2, okay, then the slope of a parallel line would be also 1/2. Slope of a perpendicular line, okay, we'll call that one M1. The perpendicular line, your second line, would have to have a negative slope. One of them has to be positive, one has to be negative, and it would be the reciprocal. The reciprocal means we flip it over. Okay, instead of 1/2, it's 2/1, -2. Okay, so if your first line had a slope of -3/5, your perpendicular line, the first line has a negative slope, the second would have to be positive, and you would flip the slope over 5/3. Okay, and that will force it to be perpendicular to the first line. Okay, so let's just look at a couple of examples. I'm not going to give you tons of examples with these. I just want you to be able to recognize them. Okay, so if I give you two lines, we're going to say, are the lines parallel, perpendicular, or neither? Okay, so for the first one, I give you these two lines, and of course I have to make a mess of them and not write them the way that you want them. Okay, 5y plus 2x plus 10 equals 0. And the second one is 2y minus 5x minus 2 equals 0. Okay, we want to see, are they parallel, perpendicular, or neither? Okay, and you really need these written in y equals mx plus b form to be able to tell what the slope is, right? If I can write them as y equals mx plus b, okay, parallel, perpendicular is all about slope, so I just have to look at that slope. Okay, so I'm just going to take both of these lines and rewrite them in slope-intercept form. Okay, so I'm going to try to solve this first line for y. So I'm going to subtract 2x and 10 from both sides. Okay, so if I do that, I'll have 5y on the left and negative 2x minus 10 on the right, and then just divide by 5. Okay, so that gives me y. Over here, negative 2x over 5, where we saw in that last graphing example, I can write it like this, negative 2/5 x, and then negative 10 divided by 5 will give me minus 2. Okay, so that's my first line. Then I'm going to go over to my second line, and I'm going to solve this one for y as well. So I'm going to add 5x and add 2. Okay, so I get 2y equals 5x plus 2, and then divide everybody by 2. And that gives me y equals 5/2 x, and then 2 divided by 2 is plus 1. Okay, so this line, we want to look at it in that format, and then this line. So we're looking at those two. Okay, so we only care about what the slope is. The slope of this line is 5/2. The slope of this line is -2/5. Okay, and I can see that those are negative reciprocals, right? The reciprocals, one's positive, one negative. So negative reciprocals means that these are perpendicular lines. And sometimes we use that symbol to indicate that we've got perpendicular lines. Oh, sorry, that's right on top of that stupid watermark. Perpendicular. There we go. All right, so we know that those are perpendicular. All right, so let's do one more of those. Okay, and again, if you want to like pause the video and see if you're going to get the right answer, that might be a good idea. So my first one is y plus 3 equals 2x. I'll write the second one on the right. That might be a little easier. Y minus 2x minus 5 equals 0. Again, of course, I didn't write them in order, so we need to solve these for y. This one's actually a lot easier. All I need to do is subtract 3 here for my first line. And my second one, I need to add these guys over to the right. Okay. So I get y equals 2x plus 5. All right. So both of those lines have a slope of 2. They have different y-intercepts, but parallel perpendicular is all about slope. It does not matter what the y-intercepts are. This one has a y-intercept at -3. This one has a y-intercept at 5. Who cares? They both have a slope of 2. They have the same slope, and that means that they are parallel. Okay. All right. So that is what we need to be able to do in section 1F. I want you to be able to find the equation of a line if I give you information, graph a line if I give you the equation, and to be able to tell if two lines are parallel or perpendicular, or neither. All right, so section 1F homework is going to be due on Friday, and we will pick up there.